In this example, we're going to use a calculator to find the decimal approximation to 4 decimal places for the cotangent of negative 41 degrees, 8 minutes. So a lot of calculators might have, like a TI-84 might have degrees in minutes, but Desmos doesn't. So I'm just going to convert that. Let's see, negative 41 degrees 8 seconds. That's really negative of the whole thing, 41 degrees and 8 over 60 8 over 60 minutes. Okay, so that can be confusing too. Sometimes you get that little decimal. What is that? That is 1.33 divided by 60. Let me just double check it. Yeah, okay, so it would be 41 degrees and 0.133 degrees. So the whole thing is negative 41.133 degrees. Okay, so just be careful that both of the minutes and the degrees are together, and then combine those and then make the whole angle negative. Okay, so I'm converting that to negative 41.133 degrees. And now we can just use the reciprocal function. Cotangent is the same thing as 1 over tangent of negative 41.133 degrees. And then we'll just get our approximation. Okay, so we'll pull out a calculator and we're going to go 1 divided by, let's see, 1 divided by the tangent of negative 41.133 degrees. Okay, so that is approximately negative 1, so I don't know what I'm in red, negative 1.1449896. But since we're supposed to approximate this to 4 decimal places, we go over 1, 2, 3, 4, and so our 9 is going to round up because of the 8, so that rounds up to 10. The rest go to 0, and so we're left at negative 1.1450. There is. So there is the value of cotangent at negative 41 degrees, 8 minutes. So just be careful on this. There were a couple things that we looked out for. Let me get rid of that. Okay, so a couple things is just being careful with this original angle. Sometimes people subtract the decimal by accident. So just make sure to add it and then make the whole thing negative, and then use the reciprocal. Because Desmos doesn't have cotangent, we'll just use 1 over tangent. In this next problem, we're supposed to find all of the angles theta if we've got theta in an interval from 0 to 360 with the given function value that secant theta is equal to 2 square root of 3 all over 3. So our first step is just to figure out which quadrants we might be in, because secant is 1 over cosine, and cosine represents the x value in the unit circle, and so x has a positive value in quadrants 1 and in quadrants 4. So we're going to be talking about those angles in quadrants 1 and 4. So cosine. Okay, so secant we have as 1 over cosine 2 root 3 all over 3, and so that means that our cosine, let's see, would be the reciprocal, where you can just set cross products equal. So you would get 2 square root of 3 times cosine of theta is equal to the other cross product, which is 1 times 3. So that's equal to 3, and then divide through by 2 root 3 on both sides. Okay, so you've got the cosine is equal to the reciprocal of that original value. So it's now 3 over 2 times square root of 3. Now if we want to get the angle, We just want to consider perhaps that's on the unit circle. It doesn't look familiar, but if we simplify this just a little bit, if I rationalize the denominator, then that simplifies to cosine theta is equal to 3 root 3 all over 2 times square root of 3 times square root of 3. That would be 2 times 3. Those 3's cancel. So what this simplifies down to is square root of 3 all over 2, which is on the unit circle. Okay, so I go to my unit circle and I notice cosine has a value of a positive square root of 3 over 2 that corresponds to the angle of 30. Okay, so I use my unit circle to determine the first angle if it's on the unit circle. If it's not, I can just use my inverse cosine, but it is on the unit circle. Okay, so then the next one would be another angle that has a cosine value, the same thing, and that would be down in quadrant 3, and that is angle 330 degrees, has also the same value for cosine. The y value there is negative, otherwise it's the same. Okay, so the other angle is 330 degrees. So I'll list them both, and I am done. Okay, so be on the lookout for any angles that are in the unit circle. Now, sometimes they're not in the unit circle. In example B, sine theta is approximately 0.6638117. That's not in the unit circle, and so I will just use my inverse sine. So I'm going to take the inverse sine of that angle, 117. All right, so go to my functions, and I do the inverse sine of the angle, so it would be 0.663838117. All right, so that angle is 41, approximately 41.5912267. And since I'm supposed to give this in to the fourth place, 1, 2, 3, 4, I look here and that 2 isn't big enough to change it, and so my final angle is 41.5912 degrees. So that's the first one. And then we have to find our second angle, and so we look to see where would sine be positive, and since sine is the y, our first angle here was at 41, about 41.59, whatever. Okay, and then so the second one is going to have another spot where we have a similar sine value in quadrant 2. Okay, so quadrant 2, we're going to find that second angle by taking 180 minus our angle, so it'd be 180 minus 41.5912, and so our second angle is 138.4088 in quadrant 2. 138.4088. And there you have it.